Welcome to my channel. I'm Zhangjing Xu. Let's look at the problem 68 in chapter 10. In this chapter, we talk about the rotational motion. We can say in this system, we get the two mass, right? MA and MB. And also, we know these two mass just do the rotational motion around the center. And this angular velocity is given. And the distance from the mass A to the center and the mass B to the center is equal, just half of this length. The first one we need to find is the kinetic energy for this system. That is easy. Kinetic energy just comes from the rotational motion for A and B, right? So we have 1/2 IA omega square, 1/2 IB omega square. The next one, we need to find the momentum of inertia for object A and object B. For A, we have the mass times r squared. Similarly, we have the IB equal to MB, RB squared. Now we get this final answer, right? You just input this quantity inside, get the final answer. The second one asks you to find the net force on each mass. So we can say these two masses do rotational motion. So the force acting on it to hold it to do the circular motion must be the central force. Agree? The central force is MA times omega RA squared. This is we learned in previous chapters. Similarly, the central force for B is MB omega RB squared. The next one, we need to repeat part A and B. Assume this axis just goes through the center of system. So it looks like the first thing we need to find the position of this center of mass. Agree? So the center of mass, we use this ephemeral equation there, and we can consider the center of mass. We consider this point as 0, right? So the mass A times the distance from the initial to this part is 0, and then plus 3 times the 3 is mass for this object B times the distance from the 0 to there is 0.42. And then we do this equation, we can get the central mass location is at there. This time, this A and B just rotate around this axis. Agree? Yes. So what it changes? It makes the distance changes. The RA and RB changes, right? So RA becomes 0.18 because this is 0, this is central mass. RB becomes this distance. Use the total distance, the total length for A and B, 0.42 minus this part, 0.18. You get it. Now you can see, just as the RA, RB changes, nothing changes except that. So we input the lower quantity inside, get the final answer at there. Thank you.